Hello again, and welcome to mole ratios. So, we've learned to balance reactions and get these coefficients out front, which in this example are 2 to 1 to 2. And those tell us the proportions in which these chemicals react. So, this tells us that however much chlorine you've got, you have twice that much sodium, and you will get twice that much sodium chloride when the reaction's over. Or, from the standpoint of sodium, you could say if you have a certain amount of sodium, the chlorine will only be half that much, 1 instead of 2, and the sodium chloride will be the exact same amount. So there's a number of ways we can use proportions to solve these. I'll try to show you a variety of solution methods as we go through these, and I suspect what will happen is you'll find one way that works the best for you, and I hope that once you've found one you like, you'll just kind of ignore the others. It's better to have one strategy that you know really well rather than try to master a whole bunch at once. So, let's say here, they tell us we start with 0.4 moles of chlorine, this, and they want to know how many moles of sodium chloride we'll produce. So, compared to the chlorine, which in this reaction is a 1, the sodium chloride is always twice that much. The ratio is 2 to 1. So the fastest possible way to do this is 0.4 moles of chlorine. That's a given. You could do something like this. The reaction gives you that there's 2 moles of sodium chloride for every 1 mole of chlorine. So you can say, I'm going to get 2 NaCl for every 1 chlorine. If you do that, the chlorines cancel out, and mathematically you do 0.4 times 2 divided by 1, and that gives you 0.8 moles of sodium chloride. Not too bad. Two other ways that you could do this. One is you could cross multiply. You could say something like this. I'll clear these from the original equation. The numbers we have up here are that it's 1 chlorine to 2 NaCl. So you could say if there's 1 chlorine for every 2 sodium chloride, then you write an equals, and you say we only have 0.4 of a mole of chlorine. So you say 0.4 moles of chlorine. I should write moles, sorry. Let me fix that. 0.4 moles of chlorine would give us X moles of sodium chloride. So if you're doing this, equals in the middle, your units must always line up. So you'll have either chlorine on top and sodium chloride on the bottom, or vice versa. And when you're solving this, you cross multiply, which means you do 0.4 times 2. You multiply the two numbers that are in opposite corners and divide by the remaining numbers. So your math looks like 0.4 times 2 divided by 1 gives you 0.8. That means your missing number is 0.8 moles of NaCl. And one last way you could do this. Up in the reaction here, if they tell you 0.4 moles of chlorine, put that under the chlorine. And then, if the sodium chloride is twice as big, that means its number down here is twice as big. So you do 0.4 times 2, 0.8. And the sodium here is also twice as big, so there again you put 0.8. So starting from this number, you think, starting from 1, what do I do to get to 2? Multiply by 2, obviously, so you do that with the moles. Same thing here, multiply by 2, you get that for the moles. That's my son came home with that one time and it showed it to me, and it's kind of nice. I like it. I'm used to doing them this way, and I'm used to being more of a good boy with my units than this, but this is totally effective, and I'll try it a few more times just so if you are a fan, you can get used to that one if you want to. So for A, we get 0.8 moles of sodium chloride, and we just got that 3 different ways. I won't do all of them this slow, or this will take 45 minutes, but I will try to mix things up a bit. 0.037 moles of sodium react. How much sodium chloride will be produced? Well, Notice the coefficients here are identical. It's 2 to 2, which is just like 1 to 1. That means however much sodium you use, you will get the exact same amount of sodium chloride. So that's one quick way to find that the answer to this is 0.037 moles of NaCl. If you do it by dimensional analysis like I did up here, it would look like 0.037 moles of sodium, that's our given, and then the reaction gives us that we have 2 NaCl for every 2 sodium. So you can say we get 2 NaCl's for every 2 sodiums. Sodium cancels. Mathematically, this means you do 0.037 times 2 divided by 2, and not surprisingly, that gives you 0.037 moles of NaCl. Fair enough? Let's try a lot more. Okay. 2.71 moles of water. We can start with that. 2.71 moles H2O. And they're asking about the amount of Fe3O4. Now, the coefficients we're talking about are 1 Fe3O4 to 4 waters. So when we write this, 1 Fe3O4 for every 4 H2O. Now, when you put in this fraction, you kind of have a choice of which number is on top, and it's important to put them so that the units cancel. We have H2O here. We need H2O to be on the bottom so that those two units cancel, leaving only Fe3O4. And mathematically, that means you do 2.71 times 1 divided by 4, which is 0.6775. 0.6775 moles Fe3O4. If you put the fraction upside down, you will know it immediately because this will happen. You'll have 2.71 moles H2O. I'm going to put this fraction the other way around. You'll get times 4 H2O for every 1 Fe3O4. Now nothing cancels. We don't have H2O over H2O anymore. If this happens to you, you know that you need to flip your fraction or you're not going to get anywhere. So always try to set these up so that you have moles of something on top and then those same moles on the bottom. That way you'll get a cancel and life will be good. For B, let's see, they start us with, I'm going to clear the reaction so we can use it again, 17.2 moles of hydrogen times, no, they want iron. So we're interested in the moles of hydrogen, there they are, and iron, there they are. You get 3 moles of iron for every 4 moles of hydrogen. And what goes on top? Remember, we want our iron to cancel, we want hydrogen to cancel, so that's the one that must go on the bottom. I'm going to put 3 Fe for every 4 hydrogen, because then the hydrogens will cancel. And for math, we do 17.2 times the 3 because it's upstairs, divided by the 4 because it's downstairs. 12.9 moles of iron. Clean up the reaction so we can use it again. If 3.55 moles of water react, how much hydrogen will be produced? We're starting with 3.55 moles of H2O. And so we're going from water to hydrogen, which means we're using the water there, the hydrogen there, and the ratio is 4 to 4. Now, really fast shortcut, if you notice that these coefficients are the exact same, that means the moles will be the exact same. So instantly we know we're going to get 3.55 moles of hydrogen. These amounts will always match. If you want to do the number crunch, then it'll look like this. We want H2O to cancel, so it goes on the bottom, 4H2O. Our number for the hydrogen was 4H2. The H2Os cancel. And for math here, you end up doing 3.55 times 4 divided by 4. And unsurprisingly, that yields us 3.55 moles of hydrogen. Fair enough? Let's press on a little more. Okay. Notice what's different with this one? Actually, I guess the italics kind of warn you about it. For the first two questions, we were nice and we said consider the balanced reaction. We took care of the balancing for you. In this one, we warn you that this reaction is not balanced yet, meaning you must take care of that first. We need these coefficients because they're an integral part of the math we're going to do. So we get to balance this before we go any further. 3 carbon, need a 3 there. 8 hydrogen, need a 4 there. That's 3 times 2 is 6 oxygen, plus another 4 oxygen, total of 10 oxygen. We need 10 oxygen on the left, and 5 times 2 will make 10. Okay. Now we're balanced and we can go on. 0.25 moles of propane, that's C3H8. How much carbon dioxide will we get? So the numbers we are using are the propane, which is a 1, and the carbon dioxide, which is a 3. So if we do this dimensionally, we'll say 0.25 moles C3H8 times, you get 3 CO2s for every 1 propane. So 3 CO2 for every 1 C3H8. And math-wise, you do 0.25 times 3 divided by 1. Gives you 0.75 moles of CO2. Not too bad. 400 moles of carbon dioxide, how much propane? Well, again, we're talking about propane and carbon dioxide, so again, we need the propane number and the carbon dioxide number. But I promised you some variety in the solution method, so let's do cross-multiplying for a few of these. According to the reaction, 1 mole of propane means 3 moles of CO2. So we can say 1 propane gets you 3 CO2. And then, for the given, they say we have 400 moles of carbon dioxide. So we're going to say, I don't know how much propane, XC3H8, and down here we have 400 moles of CO2. So mathematically here, you multiply the two numbers that are opposite corners. You do 400 moles times 1 divided by 3, and you get X is 133.333333333 moles of propane. For C, oh, they change up the species on us. They tell us how much oxygen there is, and they ask for the amount of water. Oh shoot, I wiped out my coefficients. Sorry. That was a 3, that was a 4, that was a 5. Okay. So, they want us to work with oxygen and water vapor, and the ratio of those is 5 to 4. We can say for every 5 oxygens, we will get 4 water vapor. And then they say we have 11.4 moles of oxygen. 11.4 moles O2. Remember, our units always have to match up. So if over here I put oxygen on top, on this side I must also put oxygen on top. Down here we have H2O on the bottom. Over here we put H2O on the bottom again. X of H2O. Don't know how much. To cross multiply, you do the opposite corner. 4 times 11.4 divided by 5. Can't do that in my head, at least not fast enough. 9.12. X is 9.12 moles of H2O. Not too bad. Let's do one more and then we'll pause. Unbalanced reaction. Again, they warn us. Eventually they'll stop warning you, so just watch that like a hawk. If they don't specifically say the reaction's balanced, if you don't see coefficients in here, then it's probably on you to do the balancing. So what have we got? I see 3 sulfates here. Let's get this sorted. Now we have 3 sulfates on each side, but now I have 6 hydrogen on the left. So I need 6 hydrogen on the right. And here I see 2 aluminum, so I need 2 on the left. Final check. 2 aluminum, yep. 6 hydrogen, yep. 1 sulfate. Oh, sorry. 3 times 1 is 3 sulfate, and 3 sulfate over here, so we're okay. Now, first question. They give us an amount of H2SO4, hydrogen sulfate, and they ask about aluminum. So we're talking about a 3:2 ratio. We can start this by saying 3 H2SO4. It doesn't really matter which one's on top as long as I'm consistent about it, for every 2 aluminum. And then in the givens, they say we had 0.3 moles of hydrogen sulfate. 0.3 moles H2SO4. And the question is how much aluminum, so X amount of aluminum. Mathematically, we do 0.3 times 2 is 0.6, divided by 3 is 0.2 moles of aluminum. Now they switch up. Let's clear these boxes. Next they ask about moles of aluminum sulfate, that's this, in relation to hydrogen. So if we write a ratio here, we'll get 1 mole of aluminum sulfate, that's tedious to write out, but we'll survive, for every 3 moles of hydrogen. 3 moles of hydrogen. And then in the givens they say we have 3.33 moles of aluminum sulfate. Moles Al2SO43. And we want to know how much hydrogen would go with that. So for the math, 3 times 3.33 is 9.99, divided by 1 is still 9.99 moles of hydrogen. Fair enough. Again, because I told you I'd do these a few different ways, let's do the write the numbers under the species method and see how that goes. This one does require some mental math. You may not love that, but it is kind of elegant other than that. If they say 0.3 moles of H2SO4, you put a 0.3 under here. And now if you're looking for the aluminum, what you have to do is say, with these numbers, what do you do to 3 to turn it into 2? Now that one's a little awkward, and the answer is either you multiply it by the fraction 2/3, or you multiply it by 0.6666666, or I guess you could say you divide it by 3 and then multiply it by 2. If you do any of those things to 0.3, if you do 0.3 times 2/3, you get 0.2 here. Or if you do 0.3 times 0.6666666, you'll get 0.2. You may have to round a little bit. Or if you take 0.3 divided by 3, that's 0.1, and then double it, you will get 0.2. So it works for this first thing. How about for B? For B, they say 3.33 moles of aluminum sulfate. That's this. 3.33 moles. And they're asking about the hydrogen. So we're saying, what do I do to the 1 here to turn it into 3? Answer, triple it. So take your 3.33 and triple it, and you get 9.99. it's kind of the most free flow method, or it's the one with the least rules behind it, but it is very quick if you can get comfortable with it. So again, I want to stress, I'm going to show you a lot of different ways. Don't try to learn them all. It's a waste of brain space. Pick your favorite one, get really good at it, and if people show you another method, just smile politely and don't listen too much. You really only need to be good at one of these. They all work fine. So I'll stop this video before it gets monstrously long, and we'll see you in the next one if you keep on going.